Welcome, fellow chemists. The topic introduced in this video requires you to know how to balance chemical equations and how to calculate molar mass. If you don't, it's probably a good idea to check out the videos I made on those topics, and you'll find links to them in the description. And now to properly begin this video, which is the first of 4 in my stoichiometry series. This entire series covers the mathematics behind chemical reactions, and while the terms may look or sound scary, that does not mean the concepts themselves are that difficult. Traditionally, there are 4 types of stoichiometry problems you will be introduced to. Mass isn't the first, second, or even third, so why am I focusing on this one? Because if you conduct a lab, you will probably measure out your reactants by mass, perform the reaction itself, and then measure the mass of the products. How will you check your work? You guessed it, mass stoichiometry. So I'm sticking with this because of how likely you are to apply it, but truth be told, mole mass, and mass-mole stoichiometry all get combined into the mass calculation, which we will use to answer a typical question like the one on the screen. This is a mass question because we are given 220 grams of propane and asked to find how many grams of water form. We can give ourselves a pat on the back for reading the question, but we can't answer it for 2 reasons. The first should be obvious. We have no chemical equation. Now that I provided you that, it's still not good enough because it isn't balanced. The second reason we can't answer this question is we don't have any of the molar masses of the substances involved. It's true we don't need all 4, however I suggest finding all of them anyway because you may be given multiple questions using the same equation. If you find the molar masses at the beginning, all you need to do is reference them. So why not give it a go finding all that information? You can use my rounded periodic table, link in the description, for the molar mass calculations. First up is balancing the equation. Luckily, this one is fairly straightforward, even if you did not watch my videos on this topic. To finish this one off, though, I'm going to go against convention and put a 1 as a coefficient in front of propane. Usually we don't bother doing this, but you'll see why I did soon enough. The molar masses are even easier. By the time you are finished with this topic, you will probably end up memorizing oxygen, carbon dioxide, and water's values among other common chemicals, and you won't need to bother with the calculation anymore. Propane's value, when rounded to the nearest whole number, is coincidentally the same as carbon dioxide's. With the balanced equation and molar masses determined, we can now answer any stoichiometry question about this particular reaction. But how? Inspecting the question a bit more closely, the first sentence is completely superfluous because we now have the equation described by it. This means we can ignore it and focus on the second sentence. Regardless of how everything is phrased in the question, we should identify what we are given and what we want to find. The given is always explicitly stated with a value, so in this question it is 220 grams of propane. The want is, well, what the question wants us to do, which in this case is finding the grams of water that form. At this stage, we know the balanced equation, molar masses, what we are given in the question, and what we are asked to find. This means we can start to put it all together, and for that I use a grid with 6 boxes. This grid, which mathematically is a giant fraction, helps us organize all this information into a form that is easy to replicate. What I mean by that is the same type of information goes into the same 6 boxes every single time. Starting with the top left box, put the mass given in the question, but do not forget to put the formula of the substance too. Underneath, put the molar mass of the given substance. In the bottom middle box, put the coefficient and formula from the equation of the given substance. Above that, take the coefficient and formula from the equation of the substance we want in our answer. In the top right box, put the molar mass of the substance we want. The unit in the top right box is grams per mole, and what I'm going to do may look like some illegal mathematics, but trust me. So what about the unit of the values in the middle? This part of the grid is known as the mole ratio. So the unit is of course moles. It is this ratio which allows us to convert from the given substance to the one we want in this and all other stoichiometry calculations. After filling in the grid, we can check if we did so correctly by determining if the units we want in the answer will remain after the calculation is performed. In this case, that means grams and water. The obvious ones that cancel are grams in the boxes on the left, as well as the formula for propane. Less clear is that all instances of the unit mole will cancel. The 2 in the middle are probably obvious, but how does the 1 on the bottom left cancel out the bottom right? Well, they are both below the line in the middle, but the 1 on the bottom left is below yet another line. They are not on the same level, which means they will cancel out. The only units surviving the calculation are grams and H2O, which is exactly what the question wants us to find. The math is easy from here, and this is just one way to work it out. Since this is a giant fraction, the simplest thing to do is multiply all the values on the top and then do the same for the bottom. Once this is done, all that remains is dividing the two and the answer is revealed. Remember that this number isn't the entire answer because we know that G and H2O also survive the calculation, and when we include them, the proper answer is revealed. The grid I present here is about as equation-like as I can make stoichiometry calculations. Always put the given mass in the top left. Underneath that goes the molar mass of the given substance. The mole ratio goes in the middle with the coefficient of the substance you want on the top and that of the given on the bottom. In the top right, put the molar mass of the substance you want to find, and underneath that put 1 mole. Knowing this grid isn't foolproof though, because you still need to know how to calculate molar masses and balance equations in order to use it properly. That being said, I suggest taking a screenshot of this grid because I've got one last question for you. Take a moment, pause the video, and give it a go. I'm going to choose to balance this equation first. Again, this is pretty easy if you watch my second video on the topic. Now, if you balance it slightly differently, just hold on about 50 seconds. Calculating the molar masses is also easy because 3 were used in the previous question, and so we only need to find butanes. Now we can look at the question again and start filling out the grid. The question gives us 416 grams of oxygen, so that goes in the top left. Underneath that goes its molar mass of 32 grams per mole. Finally, put the coefficient of the given from the equation into the bottom middle box. The question wants us to find carbon dioxide, and there is a 4 in front of it in the equation, so that goes in the top middle. All that remains is the boxes on the right, where the molar mass of CO2, which is 44 grams, goes on top, and 1 mole goes on the bottom. A quick check shows the units cancel as desired, and so we can move on to performing the calculation. The simplification of the values in the grid results in a numerical answer of 352, and after moving the proper units into place, we get the official answer of 352 grams of carbon dioxide. Now, did you balance it with the conventional set of coefficients? If so, the result is exactly the same. If you don't believe me, check my work using the grid on the screen now. As I mentioned earlier, as long as the equation is correctly balanced, even if not conventionally, the result of the calculation is unaffected. And on that wonderful mathematical bombshell, we have completed the first video in this stoichiometry series, and next time we will look at limiting and excess reagents. Until then, feel free to leave a question or comment, and thank you very much for watching.